Bonjour, buddies. Welcome back to another video. This is problem number 25 of the 2023 AMC8. 15 integers, A1, A2, A3, all the way up to A15, consecutive order, are arranged in order on a number line. The integers are equally spaced and have the property that, these properties, you can read it yourself. What is the sum of the digits of A14? So obviously to find the sum of the digits of A14, either there is a loophole, which in this problem it just so happens that there isn't, or you just find what A14 is first. And in this problem, that is exactly what you have to do. Okie dokes. So let's look at this, okay? So if A1, A2, A3, and A15 are all integers and they are equally spaced, milking the equally spaced here, this just so happens that we can find out what the distance between each one is, and that's going to benefit us greatly in the long run. So let's just say that the distance between each one is d, like the distance between A1 and A2 is, well, d. So, since there are 15 on the number line, this means that 14d is equivalent to the distance between the smallest number, A1, and the biggest number, A15, which also means that we can create a minimum-maximum kind of inequality. So you have 250 minus 1, so that is 249, and 241 minus 10, so then that is 231. So now that we have these two numbers, you might think that it's smooth sailing from now on. Well, in reality, it's kind of not, because at the same time, not only do we not know A1, but 231 and 249 are both not divisible by 14. However, doing a little bit of quick solving, you'll find that 231 divided by 14 is equivalent to 16 point something something, and 249 divided by 14 is equivalent to 17 something something. And you might be like, okay, yeah, no, but what is this something something? But the thing we really need to focus on here is that the integers are the integers. All of them are integers, which also means that we only need to know the integer that is between something greater than 16 and something less than 17. And the only thing that really fits that in there, this means that d must be 17. Okie dokie. So now that we know this, we know that the distance between all of these numbers is 17. However, we don't actually know what A1 is. If we knew what A1 is, we could just add 17 multiplied by 13, getting you A14. However, we don't. So we need to test this out. Since it says that A1, so A1 plus D, which is 17, has to be, since that would get you A2, has to be less than or equal to 20, and greater than or equal to 13. Utilizing the second equation here. So, however, if you put in a value that was greater than 3, you can put 3, that would be equivalent to 20, and that fits. But if you put, for example, like 4, this means that it would be equivalent to 21, and that is greater than 20, therefore it does not fit the circumstances. So A1 must be less than or equal to 3, or greater than or equal to 1. And now that we know the approximate area in which A1 is located, we can do a little bit of hijinks solving to see if any of them work. So personally, this is where my own path starts diverging and then going into a new solution. But basically, if you look at this here, since like I said, it has a distance of 14d away from A1. So if we have, since the distance is 17, we have 17 multiplied by 14, and doing a little bit of hijinks solving, we find that it's equivalent to 238. And that means that A1 plus 238 has to be within this distance. And since A1 can only be 1, 2, or 3, if we use 1 to add this, you get 239, that's too small. 2 to add this, you get 240, also too small. And it only works when you reach 3 and just barely to 241. So this means that A1 must be equivalent to 3. So we've already procured that now. So now we just need A1 plus 238 minus 17, because that would be 13d, which is what we actually need in this case. So if I minus 17 right here, this is 1, 2, 2. So 221, 3 plus 221, this means that A14 is equivalent to 224, which also means that the digits added up, the sum of the digits of A14, 2 plus 4 is equivalent to A8. Therefore, the answer is A8. So yeah, that's the end of this video. I hope you guys enjoyed, and I'll see you all on the next one. Bye-bye!